I would like to formally welcome you to the lesson that's going to change derivatives for you forever with this thing that's called the chain rule. The chain rule is what I have to use anytime I want to take the derivative of a composition of functions. Compositions, it happens when you got a function stuck inside of another function. All right, so our objective to investigate, derive, and use the chain rule. Before we can do any of that, let's refresh and warm up with a discussion involving a composition of functions. So in this first warm-up question, use the graphs of f and g to find f composed with g of 1. And I have two graphed functions right over here. Okay, so question, what part of that are you supposed to do first? What part do you calculate first here? I've got to do the interior function, which is g of x, and then its output becomes the input of the exterior function f of x. So I'm going to find from the graph g of 1, whatever its output is, I will evaluate the graph of f at that particular point. Okay, so this should be equal to f of something. I'm going to find from the graph what g of 1 is, the interior function. So the g is the top function, and at 1, it looks like the graph is equal to 2. So now I do the exterior function, which is the f of x1, and I'm going to evaluate that at 2. F of x is the bottom function, and at 2, it looks like the graph is equal to 1. So f composed with g of 1 is equal to 1. Just coincidentally, this is 1, right? It has absolutely nothing to do with that. Okay, all right, let's look at the next one here, which is essentially about function decomposition, unwinding a function into its two components, its interior versus its exterior function. Warm up 2. Write each of the functions below as the composition of two functions such that h of x is equal to f composed with g of x, where g of x is the interior function and f of x is the exterior function. Why are we doing this? Well, being able to identify the interior versus the exterior is going to help you whenever we start applying the chain rule whenever we want to take the derivative of these kind of functions. Okay. So on number 1, you might go, this doesn't even look like a composition of function. I don't see anything inside of another function, but you can think of it that way. It's the interior function is x plus 1. X plus 1 is being stuck inside of another function. So I'm going to say that g of x is equal to x plus 1. And then what function is it being composed with? What are you sticking it into? We're going to stick it into, well, think of this now here as just a big x. It's 1 over x that this gets substituted into. And so now h of x is equal to f composed with g of x. Well, this guy is going to go in for x there. Okay. All right, over here on number 2, now this one is a little bit more obvious what your interior versus your exterior function is. What part of this would you have to do first? That's this x plus 2. It's stuck inside of your sine function. So your interior function is 2x, and it's stuck inside of sine x. Whenever you go to take the derivative of this guy, you have to use the chain rule because it is a composition of functions. We can get around this one, not having to use the chain rule. You just have to use the quotient rule on it. Okay, all right then. Let's look at 2 more of these decompositions. On number 3, y is equal to the square root of 3x squared minus x plus 1. Can we see something inside of something else? I can see this quadratic is put inside of a square root. It's a composite or a composition of functions where the interior is the quadratic, 3x squared minus x plus 1, and then the exterior is just simply the square root. So f of x is equal to the square root of x. So that I would get my h of x function, or y in this case, when I take this and I substitute it in for x. Okay. Finally, number 4, y is equal to tangent squared of x. So first of all, I would probably rewrite this one as tangent x quantity squared, right? This is just the convenient notation that we use when we mean that, because it's a little easier to write. You don't have to worry about the parentheses. And if you took off these parentheses, that squared looks like it would be attached to the x. So this is the way we usually write it in trig. Okay, so now when I do write it like that, then it might be obvious what our composition is. The interior function is the tangent of x, and whatever I get for the tangent of x, I'm going to square. All right? So that brings us to our lesson target, our objective, being able to investigate, derive, and use the chain rule, which is just about what we're gonna do.